Hi everyone, welcome back to my YouTube channel Tech Classes. This is the second video tutorial and topic is Proteus Overview. Now come to the agenda for this video. In this video I will familiarize with Proteus. I will show you how to create a project and I will also give a quick demo on schematic design. Now come to the Proteus. This is the home page of Proteus and in this platform you can design schematic PCB. You can also write embedded system code and you can run simulation to see result. In this video I am going to explain how to design schematic. To do anything in this platform you have to create a project. So let us see how to create a project. There are two ways to create project in this platform. You can go to file, then you can click on new project, or here shortcut is given to directly start your project creation process. So just click here, then new project wizard will start, and here in this option, name option, you have to give the project name. Let project name is LDR sensor. I will design a simple LDR sensor here, and in the second option you can browse and select the location where you want to save this project. So let I am giving the default location. The my project will be saved inside the documents. Then next, and here you can select the size of the schematic capture platform. So here you can select landscape A4, A3, A2, A1, A0 like this. Since I am designing a very small circuit, A4 will be sufficient. So I will go with A4. And here you can select whether you need a PCB or not. Since I am not requiring, I am not going to design any PCB, so I will select don't create PCB. Then here you can select whether this project is a firmware project or not. Firmware project means you are using microcontroller and you are going to write program for it. Since I am not using any microcontroller and I am not going to write any program also, so I will select no firmware project. Next, then in the summary, last one, what you have selected so far will be shown. If everything is fine, then finish it. Now this is the schematic capture window, and this is the design space where you can design your schematic. But to design your circuit here, you need component. So you have to select component. So actually to work on these platforms, there are different modes are present in the left side, like selection mode, then component mode, then junction dot mode, then terminal mode. Like this, different modes are present. So whenever you will be requiring anything, you have to select appropriate mode to get that thing there. Okay. So first of all, what you have to do here is you have to select the component which can be used to design your schematic. So to select component, you have to go to the component mode. By default, it will be in component mode. So this is the component mode, and here you have to click on P. P means what? Peak devices. And in this keyword option, what you have to do? Now you have to type the keyword which component you are searching for. So here I need one LDR. So I will type LDR, and this is the result window. Here result of your search will be shown. So here I am getting two results. This is one, and this is the preview of this component, and second one is this one. So I want to use second one. So just double click on this component to select it. So this component is selected. Similarly, I need one register 10k. So just I will type 10k. This is a register, and you will see in the result window this result is very long. So to make it short, what you have to do now, from the category you have to select registers, and register are having different size, like from the subcategory you can select the size of the register like 3 watt, 2 watt, 0.6 watt. So 0.6 watt is the smallest one, so I will go with this one. Now in the result I am getting 4. So I will select first one, double click. Now I will also take another register 220 arm. So again I will take this register, double click to select it. Then I need one comparator, and one of the very popular comparator is LM358. This is a dual comparator, low power comparator. So I will take last one, LM358N, double click to select it. And to see the result I need one LED. So I will type LED, and LEDs come with a different color. So I will type hyphen, then which color I need. I type yellow to select yellow color. So I will just type Y. If you need green, then just type green here. Then these are the options you are getting. So this is the green LED. So I will take yellow one here. So this is the result. I will double click to select it. So these are my component to design the sensor circuit. So far I have selected 5 component: LED, LM358, and 2 resistor 10K and 220 ohm and 1 LDR. So first I will take LDR, and this is the preview of the component, and this is the orientation. You can change orientation here by clicking here. Clockwise you can rotate, counterclockwise you can rotate. So I need this component, and this is the orientation I want. So after getting the appropriate orientation, just click once on the workspace. This is the workspace. Then this component will appear here, and it will start to move along with your mouse. Now after getting the right place to put it, just click there. Then this component will be placed there, and this component has been selected. If you click another time, again it will appear. If you need this component again, then you can place it, but for the time being I don't need this component. So I will press escape to release this, and you have to click on arrow so that this component will be deselected. Now if you see, this component is looking very small. So here zoom in and zoom out option are given. I will zoom in, and this is the component size. Now it is looking good, but this is not at the right place on the workspace. So I have to adjust the screen. So this is the screen space. Just click once here, then screen will be locked, and screen will start to move along with your mouse. After getting the right orientation, you just click another time to release the screen. Now I will take another component 10K, and I want this or its orientation to be vertical. So I will rotate it, and I will make it vertical. Then I will click here, and I will place this component here. Then I will take the comparator, and I will rotate this to get this orientation, and I will place this here, somewhere here. Now I will take 220 ohm, and I will rotate it to make it vertical, and I will place this component here. Then I will take LED, and I will place this here. I'll slightly zoom in, and I adjust the screen again. Okay. Now I need power supply, so I will go to the terminal mode, and here I will get VCC, this power, and I will place this VCC here, and this comparator also requires VCC, and I will take ground, and I will connect this ground to here, and for this op-amp and for this LED also here. You can also use common ground. After that, I will click on this selection mode to deselect the component. When no component will be selected, then OR will be default selection. That means now I have not selected any component, so OR is selected. So to establish, I have to connect from here to here. So just I will click from here to between these two, then this to this, then this to this, and I will connect this pin number 3 of the comparator to here, and this V of the op-amp will be connected to ground, and pin number 8 to be connected to the VCC, and output of this comparator will be connected to this end of the register, and from here to here, and cathode will be grounded. And I want to, since this is a comparator, um, this is the unknown signal. This is the output of the sensor is given to the non-inverting terminal, and to the inverting terminal of this comparator I will apply a non-voltage. So non-voltage is nothing but one DC voltage. So I will go to generator mode, and I will take DC source here, and I will put DC source let here. Then I will connect this to this DC source, and I will set the DC voltage let at 3 volt. Now what I will do is, I will take probe, I will go to the probe mode, and I will get voltage probe, current probe, like this. I will take voltage probe, and I will just measure the output of the sensor. This is the output of the sensor, this one, and I will also see what is the voltage I am applying to the inverting terminal of the comparator. If you want to change the properties of any component, just right click and go to the edit properties, and you can change the internal properties of that component. Here in the case of LDR, what is the property of the LDR? Now it's dark resistance, internal resistance. Dark resistance means when this LDR will be kept in dark, what will the resistance? So this is a 1 mega ohm LDR. That means when this LDR will be kept in dark, its resistance will be as high as 1 mega ohm. Now let us run simulation here. Now simulation is running, and if you see, this output of the sensor is 0.04 volt, and inverting terminal voltage is 3 volt. I have set this DC, this source voltage is set to 3 volt. That means this plus terminal voltage is less than the minus terminal. So that's why output is negative. Here negative voltage means how much? Now how much voltage you have applied to pin number 4 of this operation amplifier? Since we have applied ground here, the output will be ground as long as this negative voltage, negative terminal voltage will be greater than the positive terminal voltage. So now we are getting 0 volts. That's why this LED is off. Now let us bring this torch towards the LDR so that more and more light will fall on this LDR, and when more and more light will fall on this LDR, its internal resistance will proportionally decrease, so that more and more voltage will develop across 10K, and that will be applied to this. Now see, just observe, I am bringing this LDR closer toward this sensor. Now see, more light is falling. Now voltage develop, the output voltage of this sensor is 0.4. Again I will bring this 0.8, then 1.6, then 2.5, now 3.3. Now this voltage you will see is greater than this voltage which is applied to the inverting terminal. So now in this condition, non-inverting terminal, this voltage is greater than the inverting terminal 3 volt. So that's why output will be equal to VCC, which is applied to pin number 8, so 5 volt. So that's why this LED is glowing. This is plus, so this anode is plus and cathode is already grounded. Now again I am bringing this LDR. See, sensor output is increasing 4.1, and when I will again when I will take this torch away from the LDR, less light is falling. The internal resistance is increasing, so that's why voltage developed across this 10K is decreasing, because this is a voltage divider circuit. So this is the way you can design different circuit here, and you can run simulation and see the result. Thank you for watching. So you can change the properties of the LDR here also. Now the internal resistance of this LDR become 2 mega ohm. And the properties of LDR is such that when more light falls on this LDR, its internal resistance proportionally decreases. When less light will fall on LDR, proportionally its internal resistance will increase.